Firstly, then, I'd just like to welcome everybody to today's event. This has been organised as part of our Turning the Tide Systems Thinking for a Sustainable Ocean project. We'll be showing some links about the project in the chat if you're interested in finding out a bit more and staying in the loop with all our future activities. So our event today is on examining the land-sea interface, coastal management approaches. Firstly, I'd like to share that unfortunately, one of our speakers for today's event, Becky McDonald-Lofts, who's the lead officer at the Local Government Association Special Interest Group. Unfortunately, she is unwell today and so is no longer participating in the session. We're in touch with Becky and we're looking to arrange either a follow-up session with her or if she's able to share a recording of her talk once she's feeling better, and then we'll be able to share that on our website if that is the case. All right, so we're really pleased to be joined today by Professor John Turner, who is a Professor of Marine Biology and Head of the School of Ocean Sciences at Bangor University in the UK. So John will deliver his presentation, and then after that, there'll be a chance for questions from the audience. So please do submit these into the Q&A at the bottom of your screen at any point throughout the presentation. And I'll then be asking these on your behalf later on. I'd also encourage everyone to make full use of the chat during the session. So feel free to post any thoughts or comments, questions for the audience throughout. All right, so thanks again to everyone for joining. I'll now hand over to John.
Thank you very much, Jo, and good afternoon to everybody who's come along. Thank you for attending this session. So I'm going to talk about integrated coastal zone management. And as you probably guessed, that's to do with resources, marine resources. And that first picture there on the left of the screen shows mangrove poles being cut and brought in at Lamu on the east coast of Africa. So they're a typical resource used for building, scaffolding, for construction of buildings mostly, but also as wood for other purposes. And then we can have interventions. Coastal zone management is about intervening and doing something. And an example that we will come across during the presentation is actually planting mangroves to stabilize sediment, for instance. And the whole purpose of coastal zone management is to ensure that the resources are available not only today, but for future generations. And the last picture on the right there is a picture of some young people on the beach of Socotra Island off the Horn of Africa. And I'm going to bring in some of these areas into the examples I used during the talk. But overall, the idea is to introduce coastal zone management to you. So advance slide, there we go. So here is a diagram which I think brings together the main features of integrated coastal zone management. And this was a diagram actually originally compiled by a colleague, Professor Andrew Price. And I think this is very useful because it covers three phases of integrated coastal zone management. We're dealing with data collection in order to form an assessment of the environment that we want to manage. And this is done both by looking at the existing information that is available, but also, of course, collecting field information. This is an area in which I've worked mostly. We're out in the field undertaking the field surveys. Now, the sort of data that we collect can cover a wide range of topics. It's not just purely marine biological. We're dealing with a multidisciplinary and interdisciplinary area of work here. So we will collect data on natural processes, the habitats and species that live in an environment, the uses that that environment is put to, and the impacts of those uses. We'll be looking at the socio-economics as well, and the legal and institutional structures. So all of those would get assessed, and we would compile that data. The next stage then is data analysis, where we look at the issues and options that are available to actually design an integrated coastal zone management plan. And usually a lot of that data that we've compiled would then go into a geographical information system to allow map analysis. There might be computer modeling, designing indices, and so on. And we will be looking at the specific issues that the stakeholders, the end users of this information are interested in. And then there is the data synthesis stage, where we actually formulate the plans and design the projects. So this is goal-led. We're looking at resource policies, sectoral use policies. Often this can result in some form of zoning scheme or a marine protected area system of some sort. And of course, in order to reinforce those systems, we need appropriate legislation, and that's backed up by education and awareness. So that's the sort of overall concept of ICZM. I can't address all of those subjects today, of course, but I'll give a flavour, particularly in a case study towards the end. Now, the acronym ICZM for Integrated Coastal Zone Management can actually appear slightly differently depending on the emphasis of the area and the project. So we often see the heading Integrated Coastal and Watershed Management and Integrated Coastal Resource Management. Essentially, they all mean the same thing, but of course that last one deals particularly with perhaps resources, particularly, for instance, fisheries resources. The watershed management is really one of the more useful terms because we're dealing with usually the top of the watershed out to the edge of the continental shelf, as is illustrated in the image there from Rodrigue in the Indian Ocean. And integrated coastal zone management really says the same thing, but in a more overall way, doesn't actually specify the watershed. But here in Rodrigue, we can see it's a small island in the Western Indian Ocean. It's a state of Mauritius. And it's an island that is quite high. It's a volcanic island, and following the removal of vegetation, the island has suffered a great deal of erosion. And you can see in the pictures some terracing there. And cattle have been brought in as well, and they tend to break down the terracing. But the result is that there can be soil runoff into that large lagoon that you can see with the coral reef right out near the horizon there. And then, of course, it drops off into deep water. So we can see the whole watershed in that example. And that is the area which we would plan to manage in integrated coastal zone management. I think one of the important things to realize is that coastal zone management it's a tool for the conservation and sustainable management. And it covers the marine, the coastal, and the freshwater biodiversity that lives in a place. So we'll be talking about a case study on Socotra later on. And the image there shows the coastal zone of Socotra. So essentially here, we're looking at this granitic mountain range that you get in Socotra, which is about as high as Snowdon in Wales, where I am at present, through the waddies out to the sea. So the coastal zone management is a tool that can be applied to manage the biodiversity in that area. So of course, we're looking at that freshwater biodiversity as well as marine. And integrated coastal zone management is also a process. It's the process for decision making. Decisions are to prevent, control, or mitigate adverse impacts from human activities throughout that watershed and coastal environment. And where possible, the intention is to restore degraded areas. Now, what's really important when undertaking integrated coastal zone management is that you have a diverse team. And you can see that in a project we ran in the Philippines here, a group of people who are essentially the stakeholders. And the stakeholders are really important because in that process, it begins with issues identification. And those issues come from the stakeholders, the people who are concerned, they are invested in the environment that's going to be managed. So we begin with identifying the issues, and that leads to dialogue among all the interested parties through a process of public consultation. And we want to build cooperation during that process. And then that forms the basis of the coordinated action, which will lead to being able to integrate the management that we want to achieve. So the stakeholders come from public and private sectors. They may be resource owners, they may be managers and users, they may work for non-governmental organizations and the general public. So in a tropical environment, it could be everybody from the Minister of the Environment right through to local fishermen, people operating glass-bottom boats for tourism. All of these people are involved and have a say. So if we sort of break down what integrated coastal zone management really means, I think the first question is, what do we mean by integrated? And integrated, if you look it up in the dictionary, it means various parts or aspects linked or coordinated. So what are those aspects? And really what we're looking at are objectives, and these need to be specific and smart as possible. We'll see that at the end. Instruments that can help us meet those objectives. We need to combine in policy. We're bringing in both land and sea sectors and various different sectors of the economy. We're looking at administration, who actually has jurisdiction and management of areas in this zone. We, of course, have the terrestrial and marine components, and administration differs and ownership differs greatly in the marine and the terrestrial environments. And we're having to look at all of this through time and through space. I mean, many integrated coastal zone management projects can take a decade or more to come into existence. And they're often based on data going back much further. And what we need to do is unite the disciplines in order to produce a coastal zone management plan. There's an example there of a typical coastal zone environment. This is in Sinaloa in Mexico, where you can see sort of the encroachment of development into an area that was mangroves on the coast. And we can see that this is clearly an area that does need to be managed. And at the moment, there's a clear boundary there. But of course, how's that going to change? And what are the implications of the changes that are going to occur? So coastal zone, if we define that, and we're really talking about the coast and the watershed, it extends from the upper reaches of the coastal watershed to the adjoining offshore systems. So of course, in small island states, they're fantastic because you can see the whole watershed. You can stand on the highest point, look down the valley towards the marine system, and you have quite a good understanding of the area that you're dealing with. But often the end of that coastal zone will be the edge of the continental shelf, or where an island drops off, for example. So it encompasses the terrestrial, the freshwater, and the marine ecosystem. And of course, what's important are all the human impacts that occur during that journey from the top of the watershed to beyond the reef in this example. Humans are involved in all the areas of that, because they might be, for instance, pig farming, grazing cattle. There may be pollution going into that water. Then there may be some form of mining, for instance, down nearer the coast. And all of these effluents could end up into that coastal zone, together with, of course, soil that could be brought from land management practices. Now, activities on land are largely controlled by planning legislation that many are familiar with, and there is ownership of land. But offshore, we tend to have planning managed and controlled by sectoral legislation. So it varies in different countries. Clearly in the UK, we have the Crown Estate involved with the immediate coastline, and we have territorial limits as well. But you go to other countries, for instance, Japan, and the seabed is managed by one authority. The pelagic environment, the depth, the profile of the water managed by another authority, and then the surface by yet another authority. In the UK, we have, of course, areas for military to use that are put aside. We have various fishing areas, and of course, now that we have conservation zones of different types, there is legislation through the Marine Coastal and Access Act that is helping manage that marine environment. But it varies around the world. And if you go to America, there's an amazingly complex and overlapping system of basically management of marine environments. So M is for management. And what management really means in terms of integrated coastal zone management, it's the cycle of information collection, planning, decision-making, and then implementing something and then monitoring. So if we go to our Rodrigue's example again, here we have an issue which is erosion. Basically, the British back in the 1960s were responsible for removal a lot of the vegetation on these islands to convert it into an agricultural economy, a breadbasket essentially for Mauritius. But this being volcanic soils, they're quite fertile, but they also quite quickly get eroded away, particularly by wind and rain. So the problem in Rodrigue's is that a lot of this soil is coming down the watersheds and ending up in the lagoon. And the result of this is that fisheries become unproductive because we get essentially a muddy environment close inshore rather than a healthy coral and seagrass-rich lagoon area. And some of this soil even reaches the coral reef, and that changes the structure of the reef. The sedimentation tends to kill off corals. It reduces light penetration, and the corals use a lot of energy to actually reject sediment. So, for instance, in this example, a PhD student of mine, Emily Hardman, was involved in actually monitoring the soil that is reaching the reef environments. And you can see her in the image there, assessing the settlement in those environments. So that was the information collection that we were doing, alongside lots of information on actually the structure of the corals and the reefs and how they were responding. Now, previously, the terracing had been successful, but the bringing in of cattle and so on, and people taking some of the terracing to rebuild houses, means that erosion has accelerated. So one thing they've done is dug essentially pans to collect the sediment and let it fall out by gravity into those pans. But also they've had a project of planting mangroves in order to stop the sediment transferring out. So that would be the management implementation. Once that's done, of course, you carry on with the monitoring. So go back and measure how much sediment is actually reaching the lagoon and coral reef. So that is an example of the cycle of management, and it may be that with time, further implementations are required, interventions that might stop the sediment. You can see that the mangrove was probably planted by foresters in this situation. It's very irregular, it's very regular rather, which is not great for biodiversity, which would prefer probably a more irregular planting. And these are some of the recommendations that, of course, can be made. Now, integrated coastal zone management works by building on an understanding of the specific conditions of the area of interest. And what we need to do, if we're going to be successful, is to work with rather than against natural processes. And what we want to do is ensure that decisions taken today do not foreclose on future options. In fact, in this case, the example here comes from the Seychelles, a picture of Mahe Island in the Seychelles, which is a very high island with a mist forest on the top. And because it's very vertical, there's very little place for human infrastructure. Right at the top right, you'll see the airport that was built in 1972 on essentially land that will have been reclaimed. And we can see now various islands which are actually built on the top of coral reefs. And the coral reef in the middle of the image there is one that has now actually been built on as well. They basically fill it with sand, tamp that down, and provide a platform for building. And the harbours and other structures, much housing in the Seychelles, have been built on top of some of these reefs. Now, in the very background, you can see a marine protected area. It's the island of St. Anne's, where most visitors to Mahe actually go. It's a real important revenue earner for the Seychelles. But of course, that particular set of coral reefs and marine protected area has been put at risk by basically dredging to build on these coral reefs. And that means then that you've lost those reefs. You're never going to get them back. We can't sort of return those islands to coral reef status. So we're foreclosing on future options. And that's something that's really important to consider. Participatory planning is essential to develop consensus. That's an important concept of ICZM. And so we've got to ensure that all the relevant bodies are actually represented. And as you can see from just that example I've given, we've got all sorts of different infrastructure around those islands, including a marine protected area. We'll have everything from tourism to, for instance, marine biologists and conservationists wanting to protect those reefs. They're all going to be involved in this process. And therefore, we have to have this combination of environmental science, law, economic policies, education, all the voluntary measures involved in this process. Now, we require information to make decisions, and that information needs to be essentially issue-led. We need information based on the actual things that concern people, not necessarily the data that scientists want to record. It needs to be presented in a form that is understandable by the end users, and it needs to be regularly readily accessible, and it needs to be up to date, and as I've said, integrated. We need it at an appropriate scale. So, one problem really with much science is that it's done at a localized place and maybe over 2 and 3 years. And what we need is data from the extent of a coastline over a long time series. And we need that data to have been standardized. So the variables need to have been well defined and the measurements taken in the same way with the same methodologies. And of course, that doesn't happen often if you've got multiple studies. Often that data is somewhat different. And the example in the picture there, a scientist actually snorkeling amongst fishermen in Mauritius trying to collect data. And when we work in Mauritius, we standardized that data collection over many years to get an integratable data set. And that data needs to be useful. So here in Rodrigue, we're looking at the coastal zone. This is a small line. It's only got 37,000 people. And the government authority there isn't at a high level of knowledge in terms of environmental science. And most of the people working in government have secondary school qualifications, but often not higher. And raw data is only useful to decision makers when we have put it into an appropriate context so they can use it. And it's got to command their acceptance. So an example here on Rodrigue is octopus fishing. Octopus is a really important part to the local economy. People use it as a mainstay of protein. And a lot of the women in Rodrigue will glean from the reef at low tide. They'll go out and they'll catch octopus and other organisms in very low water. In the deeper parts of the lagoon, fishermen will actually go out, and this is mostly the men with long-handled spears to catch their octopus. And they'll go out usually in boats out to the edge of the reef to undertake this. But the catch of octopus has dropped from over 775 tons to just under 270 tons per year, prompting an intervention. And on the basis of data collected, the government decided to introduce a closed period in August and October to let the octopus recover. You'll probably know octopus are short-lived organisms and they can recover and grow quite quickly. Now, this is how we would normally present data in a scientific paper or a report, but that isn't very suitable to people in government, for instance, and local people, particularly if education levels are not enormously high. They're not going to understand necessarily everything such as error bars and this sort of information. However, using a geographical information system is much more useful. So here is the island of Rodrigue. It's about 16 kilometers long, but with this very large lagoon that covers just under 250 square kilometers. And what we can see here is the coral reef around the edge. It's closer in some areas than others, but you'll also notice these deep channels in blue that wind through parts of the lagoon. Now, we surveyed this reef, and what our surveys were number of octopus per 10 meter by 50 meter transects. And the number of octopus goes up to the biggest circles, which are 10 octopus per 10 times 50 meter transect. And the color refers to the substrate. Now, what you can see on those northern shores, where particularly the ladies go out and glean octopus from the reef, they're very exploited. The circles are very small. Whereas if we come down to the southern lagoon, you can see there are far more octopus still present. And that's because the ladies can't get across that channel, which is actually 72 meters deep. But we go down to the bottom left, the circles are much smaller, indicating less octopus, and that's because the men who keep their boats in that shallow bay that you can see on the left of the island, if you go vertically down from there, what we see there is the area where the men are capturing octopus. So it's far easier to tell the story through a GIS. And the effects of the temporary fishery closure that resulted from this are very evident here. The octopus were declining until 2012. When this closed season was put in, the numbers of octopus increased. And since then, we've seen the octopus fishery return. And if we look at it just in 1 year, if in the graph on the right, you can see that there's been a closure in September, and then October, November, December, there's a recovery following that of the octopus. So I'd like to finish with a case study that sort of brings a lot of these concepts together. And this was the United Nations Development Programme Global Environmental Facility Project on the conservation and sustainable use of the biodiversity of the Socotra Archipelago. Now, Socotra belongs to Yemen, and this was before the war in Yemen at present. So we were able to gain access. It was a $5 million collaborative project, involved the Senckenberg Institute in Germany, which is equivalent to essentially our Natural History Museum, the Royal Botanic Gardens, Edinburgh, the Yemen government, ourselves for the marine environment. And it's a spectacular location. You can see here Socotra on the Horn of Africa, despite the fact it belongs to Yemen. And it's interesting because its northern coast has coral reefs. Its southern environment has actually kelps growing due to upwelling. And it consists of a series of islands making up the archipelago, but it's only the main island of Socotra which is occupied. Fishermen sometimes camp out on the other islands. And we undertook this coastal zone management project. The biodiversity of Socotra is spectacular. Here we can see the dragon's blood trees, Dracania, which are, they look as though they belong to a prehistoric environment. In the middle picture at the top there, the frankincense trees. We have these trees that grow in really arid environments in the middle there. On the left at the bottom, a big, very dry mangrove. And then a marine environment that when we went in the late 90s and 2000s for this project was pretty much pristine. And the people on the islands are Socotrans. They're of an Arabic descent. Some of them actually from Somalia, but they're mostly Yemeni Arabic. And our project involved actually looking at all the shoreline habitats and looking at the deeper water habitats in the coastal zone down to about 15 meters. And we documented all these habitats using remote sensing. It was very challenging because over most of the island there are no roads. So it was a project which involved actually just going out, camping, undertaking snorkeling and diving studies. And at the same time as we were doing this, partners from the Royal Botanic Gardens were looking at land use on the island. And this is the integrated coastal zone management project that we came up with. Now, I'm aware this is going to be quite small for you to see, but if we start at the bottom and look on the left-hand side, that box summarizes the scientific biodiversity studies on the reefs, in the mangroves, of seabirds, turtles. All of these were examined. Also terrestrially. So we had people from the Royal Botanic Gardens doing terrestrial surveys of particularly the species of flora that were found on these islands. Many are endemic. Then if we go right across the right-hand side, that bottom box looks at the traditional uses of these resources, whether it's goat herding, fishing, growing of a certain number of crops, but also more recently there's been road building, collection of firewood and so on from the mangroves there as well. And in the middle, what's represented there are the environmental and education and awareness campaigns. So the project promoted outreach officers in the villages. We went out to the villages to talk to people, and this was literally drawing maps in the sand through interpreters over what people understood, what they wanted to protect. Once we had all that data, that was the data collection phase, we integrated that data during a meeting in Sana'a, in the capital of Yemen, where as a group of scientists, there are about 64 involved, we formulated a plan to protect the coastal and the marine environments and some of the high terrestrial environments. Then in the next stage, we went out to public consultation. We went out back round all those villages explaining what the plan meant. And then that went through to acceptance to create the zoning plan. And I'll just show you very briefly what those zoning plans look like. I haven't got time to go into the detail, but we followed the IUCN categories of marine protection. So the red areas are our core marine protected areas, and they have buffer zones around them in blue, and then general resource use zones in the grey and yellow colours. And we define what can occur, what practices are allowed in each of those areas. And our colleagues in the Royal Botanic Gardens of Edinburgh did the same for the terrestrial environment. And what we did then is try to combine these protected areas. So where possible, we had both terrestrial and coastal, and then further out marine protected areas. So the red here are the core areas, some on land, some in the marine environment, protecting the watersheds wherever possible. Now, this project was successful. The zoning plan received its presidential decree in 2000. It became a man and biosphere reserve under UNESCO in 2003. And it became a World Heritage Site in 2008, with the big lagoon that you can see in the picture here on the right, becoming a Ramsar Convention protected wetland. So it was a successful project. So I'd just like to end now with a conclusion which just highlights some of the characteristics of a good ICZM process and plan. It needs to be issue-based. There needs to be a good reason to have the coastal zone management. It might be erosion, for example, or it might be a decline in fisheries yields. It needs to be clear and persuasive, because you're dealing with a lot of organizations, local people. You've got to talk in language that everybody can understand, and you can persuade government ministers to basically enact the plan. It needs to be implementable, which means it's got to be within the capacities of the agencies that are involved. And sometimes that might mean the creation of a new agency. Well, I'll give an example of that in a moment. It's got to be supported by factual data. So at the outset, you've got to go and collect that data, or bring together, compile data that has been collected before. And it's really got to be supported by those that are affected. So the planning process must be participatory, and it needs to be popular. You need to engage people. And then the plan outline needs to have this sort of structure. So we need an introduction which anticipates the questions that decision makers are going to ask. The whole plan needs to revolve around that. It's got to be informative. You know, what we're trying to do is push through a plan overall. So you've got to anticipate the issues coming up. You've got to describe the site profile, obviously, in terms of the physical, biological, but also the socio-economic aspects. We've got to focus on real issues. Are they coastal resource degradation, fisheries declines, or tourism or erosion? That there'll be something that is the main issue. And we need the local people to have a vision and a mission. What do they see the state of the environment being in the long term? And what is the general thrust of the organizations that are involved to anchor this vision? So that vision and mission is really important, and it can change with different generations. Older people may have quite a different view compared to younger people. And we saw that when I did a coastal zone management project in the Cayman Islands. For goals and objectives, we've got to decide what we want, which is to match that vision and mission. So it might be a high quality environment, right? It might be aiming to restore damaged habitats. And then we describe the management strategies and activities, the options that are available, the solutions we've decided upon, the way we've consulted with local people, how often we will review, and how flexible we can be. And then we need an agency to operate this. It could be multiple agencies across government and NGOs, or like in Australia for the Great Barrier Reef, because they had the Queensland government as well as the state government, they invented a new organisation between the two, which was the lead agency, the Great Barrier Reef Marine Park Authority. So sometimes a new agency is the best way to achieve the results. And then we need an operational plan. How are we actually going to implement, cost, monitor, what sort of indicators are used, over what time? And I suppose we should just finish on why might integrated coastal zone management fail? Because it quite often does. I get my students every year to do a review of integrated coastal zone management projects around the world, and there's over 40 students, so they each present a different one. Some succeed, many fail the integrated coastal zone management. And this is often because there's a lack of agreement of what is the coastal zone to begin with. Are they actually getting to the top of the watershed in their planning and out to the edge of the continental shelf? Sometimes political boundaries are used rather than ecological ones. And of course, marine organisms don't understand our political boundaries, neither do marine processes such as tides and currents, for example. There's another problem that often people treat the coastal zone as a common property, particularly the marine part of it, that everybody should have access, everybody can fish, everybody should have ownership. And that is not always the case. There is a lack of awareness of coastal zone problems because often many people just simply can't see what's going on underwater, so that the problems are often hidden. As we've said, there's got to be a motivation. It's got to be issue-based for ICZM. And there are problems if there's administrative fragmentation. We need an organization or a ministry to lead. There can be lack of clearly stated goals, and the whole point of discussion with end users and local people is to make sure that the goals are very clear. And what we've got to ensure, there isn't dominance of short-term management over long-term planning. And often governments are there for 3 or 5 years, but their planning can take a decade or more. And then, of course, we've got to run that project for much longer. So these are long-term projects. Sometimes there's simply inadequate information on which to base decisions, which means you've actually got to go out and get that data before decisions can be made. And finally, I think a big problem is when there are attitude problems or antagonism to the politics and the economic aspirations at a particular time. And this can often bring integrated coastal zone management to a standstill. So that is a rather quick overview an introduction to integrated coastal zone management. I hope that you've found that useful, and of course I'm happy to answer any questions. So thank you very much for listening.
Oh, that's brilliant. Thank you so much, John. Yeah, that was a very interesting presentation and really good to have it kind of different case studies woven through there. So yeah, thank you very much. So yeah, we've still got a bit of time left for some questions. We've had a few come in through the Q&A. So yeah, I can pose these to you. And if anybody has got more questions that they'd like to ask, then please do drop them into the Q&A box now or as we go. So the first question, somebody's asked regarding the impacts. I think this was something you mentioned on one of your first slides. So what official, not siloed data is available regarding pollution of our seas via the coastline?
It's very variable in different countries, of course. And one of the challenges often is checking what data is actually available. And sometimes, it's held within authorities or ministries. When we worked in Mauritius on a big sewage sanitation project, we had to get a lot of the data on water quality from a government organization that held that data. And it took some time to be able to get that data. They're not always willing to present it unless, of course, the government is involved in the project. But if that data doesn't exist, then it can be a real challenge to get sufficient data over a long enough period of time. And you do need to assess the quality of that data because particularly in some developing countries, it might be collected at a fairly basic level, and it may not be as regular as it need be. It may be not collected with standardized methods. And so I think you've got to be quite critical of that data and understand it to begin with. So data collection is always a problem. And of course, you have greater confidence if you collect your data yourself, but that takes a lot of time, and you don't always have a big enough team to collect data from the social, the economic, as well as perhaps the environmental aspects. I hope that answers your question.
Okay, yeah, thank you, John. So yeah, I suppose very kind of key to get those collaborations going right from the start of the project then, and yeah, being able to get access to the data that you need. So we have another question. So somebody's asked, integrated coastal zone management is a great example of systems thinking in practice. As you described, there are many components of integrated coastal zone management. Has this approach been done well in practice, and what have been some of the key challenges of delivering this approach on the ground?
A very good question there. And yes, the real challenge is bringing together a multidisciplinary team and getting them all to work together. They don't always have to be in the field together, because you can have different teams going out at different points, but you really need to meet and to work things out together. I think that's absolutely critical. So having the multidisciplinary team is really important, but that team needs that aptitude for being interdisciplinary and understanding what others are promoting. On project we did in the Philippines, we had religious experts, for instance, and we were dealing in stakeholder organizations with multiple languages. And the complexity of actually doing this starts to really hit home. But absolutely critical is the collaboration from the very beginning of the project. It's going out to local people and engaging them. And often it helps if that is actually fronted by local people rather than, say, UK scientists or other scientists parachuting into a different place to undertake this work. So you've got to be on a level to talk to people. I think that really is important. In the UK, if we're UK scientists, that's much easier. And we've got organisations from local authorities to the Marine Management Organisation, the Joint Nature Conservation Committees, that can all help in that process. But when you're working overseas, it can often be more difficult who to bring in to that team and who you naturally need to talk to. So it really means being open as possible from the outset and taking people with you, not just saying we're going to do this, but saying, what do you want out of it? What is your vision for the marine environment and coastal environment? And get their input and take them along in identifying the issues. What is important to those people? So we're really dealing with issues that are locally based wherever possible.
Oh, thank you, John. Yeah, and I suppose following on from that then, are there, like, through your experience, have you found that there are key groups of people, communities of people that, getting those people on board would really support the success of the project?
Definitely. Any sector or part of the local economy and so on that uses the resources of the zone, so fishermen, tourism, people involved in harbours, people who operate boats, people, for instance, who might be mining along the coast or involved in aquaculture. All of these sorts of groups of people are absolutely critical to the success, because you might want to start deciding on implementing something and it will affect one of those particular groups. For instance, producing a marine protected area that has no-take regions, then that will often mean that you can basically cause a displacement of fishers. And they might not always be happy with that. So you have to bring them into the conversation and you need to explain what are the benefits of the strict no-take area. And often that will increase fisheries because you get an overspill of that area and fishermen can actually fish around the edges of that protected area and their fishing yields can increase. So it's explaining the advantages of what you're doing can often help.
Okay, thank you very much. We've probably got time for maybe just one more question. So yeah, one that's come through. So you did speak a little bit about this actually through your presentation, but so how are coastal areas typically selected or prioritized to undergo integrated coastal zone management?
I think the answer to that is usually what area is relevant to the issue. So, for instance, in Sri Lanka, a long time ago, the issue was basically erosion around the whole of Sri Lanka. So, you're dealing with a whole country. Some of our recent work in the Cayman Islands, there are 3 islands there, and a bit like Socotra, we worked around the whole archipelago in that case and drew up a marine protected area system, which was essentially an integrated coastal zone management project. So the area can vary. In the UK, for instance, we'll often take a particular area of coast for an integrated coastal zone management project. It might be a very large bay, or it might be something like the North Wales coast, for example, where there are particularly new developments such as marine renewables, both tidal turbine driven and wind driven systems. At the same time, it's an important fisheries area, a tourism area. There have been plans perhaps for tidal lagoons along that coast, just as there have been in Cardiff and Swansea. So then your area is a bit more defined because it's where are these developments going to have the greatest impact. So the scale can vary hugely, but usually for biodiversity conservation, the larger the better. We're involved currently with a marine protected area in the Chagos Archipelago in the Indian Ocean. It's rather controversial, but that area is the size of France. So, the area that you wish to manage can be extremely large. And what we've seen in recent years is this growth in marine protected areas. And within those, there needs to be integrated coastal zone management, particularly if these areas are inhabited.
Okay, brilliant. No, that's all really useful. Okay, so I think that's probably about all we've got time for today. So thank you very much, John. We've actually had one last question come through. If you have time to answer this quickly, John. So someone said, do historic landfills ever come up?
They do, yes. And I think actually we can go further than that. It's history, culture and landscape are really important in many of these projects. Okay, it wasn't an ICZM project, but it was an environmental impact assessment project that we did in Oman. And actually all along the coast were, for instance, ancient constructions, small temples, for instance, built out of coral. There were middens that were really interesting. And all of these are important from a cultural and historic aspect. But then, of course, we can also go to places like the Cayman Islands, where you've got a large refuge tip. And islands often have a problem with getting rid of waste. So historically, there can be a very big area of waste on the coast, which, of course, leaches out into the marine environment. And because of perhaps sometimes a lack of legislation, so on in the past, you don't really know what is leaching from those tips. And that, of course, is always something that needs to be built in. You need to understand what you're dealing with. So it needs assessment. It might need almost certainly monitoring longer term, and that will be part of the integrated coastal zone management.
Great, thank you so much, John. Yeah, thank you for sharing all of your insights today. It's been really interesting to hear. So just to then wrap things up, so this forum has been recorded and we'll be making it available on the IES website and on our YouTube channel within the next week. If you're now watching back on YouTube, then do subscribe to our channel and like the video, and make sure to subscribe so we can get you notified of new content. So yeah, that is everything for us today then. So thank you to everybody for joining the session. Really hope that you found it beneficial and useful today. If you're an IES member, then don't forget to log this as part of your CPD. So you can do that through logging onto our website and using our tool. And lastly, do make sure to sign up to our mailing list for the Turning the Tide project if you haven't already done so, and keep up to date with the rest of our activities. We'll put a link in the chat for that again. So yeah, just to say another massive thank you to John. Yeah, it's been really great today. So thank you.
So thank you. And my email is at the end of the presentation. If anybody wanted to contact me, it's j.turner@bangor.ac.uk. So I'd happily chat on any more if anybody wanted to contact me that way. So thank you very much for listening, everyone.